Hello everyone, so today is math again, and we are going to do polynomials. And today I want to teach you how to do polynomials, remainder theorem, and factor theorem. And I hope you can do all of those questions in the exam. So firstly, let's talk about polynomials. So what is polynomials? Well, the polynomial is a type of function that has the general formula of that. And for example, like x plus 1 or x to the power of 3 plus 3x plus 2, they are all polynomials. However, 1 over x is not a polynomial because 1 over x is x to the power of negative 1, and the power of polynomials have to be greater or equal to 0. So that means the number 2 can be seen as a polynomial because 2 equals 2 times x to the power of 0. Okay, so that is polynomial. It's not that difficult, right? Okay, let's talk about long division. Well, long division is very similar to our normal division when we only do numbers only. For example, 2077 is divided by 31. So what should we do first? I think most of you should know how to do this. We do 6 at here and we times by 6 to 31. We get 186 and then we got 217 and we have 7 here and equals 0, which means 31 times 67 equals to 2077. So it's the same as doing here. So we have two polynomials. One is x to the power of 3 plus 2x squared minus 11x plus 6 is divided by x minus 2. So what should we do at first? We should try to cancel the higher powers, which we do x to the power of 2 here, and we times x to the power of 2 by x minus 2. We can get x to the power of 3 minus 2x squared. And we subtract this. We will get 4x squared. And now the negative 11x comes to here. And we do the same thing again, which is plus 4x. And 4x squared minus 8x, which will become minus 3x plus 6. And here we just do minus 3, and we got minus 3x plus 6, which is equal to 0. And that means x minus 2 times x squared plus 4x minus 3 equals to x to the power of 3 plus 2x squared minus 11x plus 6. Well, the goal of to solve long division questions is to try to cancel the higher power. So for example, we try to make the x cubed disappear by subtracting another x to the power of 3. And we will try to make x squared disappear. We do another x squared to minus subtract them. And in the end, we should leave a polynomial that has lower degree than the divisor polynomial. What does this mean? Well, it just means we need to have a, so like here the divisor is x minus 2, and this polynomial has its degree is 1. So we should end up having a polynomial that has the degree equals to 0, which is a number, and we end up at 0, which is correct. Okay, so that is the whole thing of how to do long division, and there are some more exercise at the back, and I will show you at the end of the session. And now let's move up to remainder theorem. This is a very important theorem because you can use remainder theorem to get factor theorem. Let's assume a polynomial px that is dividing x minus c. From here, we can see that x squared plus 4x minus 3 times x minus 2 equals that polynomial. And so here we can write that px is equal to x minus c times qx plus r, and the r is just remainder. And at this case, remainder is just 0, so we don't need to add anything. Now we substitute x equals c, because we know for polynomials, x can be any number, any real numbers, and you can pick any numbers as you want. So you can pick x equals 0, x plus 1, or anything. But here, x equals to c is very important because the pc is equal to c minus c times qx plus r. And we know c minus c is equal to 0, and 0 times anything is equal to 0, which means pc equals to r. Well, this means that px is equal to x minus c times qx plus pc, and the remainder equals to pc, which is basically what the remainder theorem is talking about. So the theorem in words: if a polynomial px is divided by x minus c, the remainder is pc, and which we got this already. So now let's have an exercise. Find the remainder when this polynomial is divided by x plus 1. Well, let's do this, shall we? Well, so it's 4x to the power of 3 minus 2x squared plus 5x minus 8. Well, now let's consider this. I know we can use the long division, but we should try to use the remainder theorem. What the remainder theorem talks about: if it divides x minus c, then the remainder is pc. So here, we are dividing x plus 1. And in this case, c is equal to negative 1. And now we can use the formula, which is we just try to find what is p minus 1, because this equals to the remainder. And so let's just substitute. So 4 times negative 1 to the power of 3 minus 2 times negative 1 to the power of 2 plus 5 times negative 1 minus 8. Well, this you can solve it. This is negative 4 minus 2 minus 5 minus 8, which is equal to negative 19. Yes. And you can check this by doing the long division. Okay, so that is remainder theorem, and let's move on to factor theorem. Okay, factor theorem. So we have already know that px is equal to x minus c times qx plus pc, and this is from the remainder theorem we just talked before. So let's assume that there is a pc that is equal to 0. Let's assume that. So what will happen? PC becomes 0, which means Px is equal to x minus c times Qx. And what does this mean? This means that x minus c is a factor of Px. And that is what the factor theorem is talking about. Theorem in words: if a polynomial Px there is a constant c that Pc is equal to 0, then x minus c is always a factor of Px. And we have just proved it here. So it is also same for ax plus b, such that if p bracket negative b over a equals 0, ax plus b is a factor of Px. So now we also have an exercise. Does x to the power of 3 plus x squared minus 3x plus 1 have the factor of x minus 1? So how do we do this? We can just simply substitute x equals 1 into this equation, and let's just check if this Px is equal to 0 or not. If it equals to 0, which means that x minus 1 is a factor, and vice versa. So let's just check. 1 to the power of 3 plus 1 to the power of 2 minus 3 plus 1, which is equal to 0. And that means P1 is equal to 0, which means x minus 1 is a factor. And now that is the end of the session. And there are some exercises I have written for you. And you can pause the video and do all of those. And these are all appearing in our textbook from page 11 to 20. And yes, that is the end of the session. And thank you for watching this video. And yeah, I'll see you tomorrow.